Again, welcome, fifth grade DGF math students. We are going to go through Chapter 8, Lesson 8 today. So I'm glad you could make it back again. As you can see from the last video, I decided to hack some of my hair off, took the old scissors right in my classroom and just started cutting. So little crazy, but it's better than having it. It was getting kind of itchy on my neck. It was just way too long for me. So let's go ahead and get started with Chapter 8, Lesson 8 today. Here we go. Hopefully it's shorter than the last one. The last video got a little bit long on 8-7, but we'll see what we can do. Okay, so that should be the correct way right there. Chapter 8, Lesson 8. You will be able to follow along in your book on page 371 of your math activity book. And again, you only need to do the problems that I do with you or I ask you to do. All right, let's go ahead and get things rolling. Okay, bathroom break, really? No, we literally just got to class. I mean, you walked in the door, you sat down, no, you should have taken care of that in between class. No, unless you're going to pee your pants, then yes. Okay, so chapter 8, lesson 8. Let us analyze a composite solid figure. Now, these are going to look kind of confusing, but what you need to know is a composite figure here. All we're going to be doing is looking at multiple shapes kind of put into one shape. So as you see here, you almost have this kind of like a, I don't know, like a sideways or upside down sideways L or something. But what they're saying is we have two different shapes, like a rectangular prism here and another rectangular prism there. And we're going to have to figure out the volume of all of them. So a composite solid can be made by putting together two or more rectangular prisms. To find the volume of such composite solids, divide it into individual prisms using the formula where V, again from the last video, V stands for volume. Volume is equal to the length times the width times the height. Now notice the dots in there, something we've worked on this year where the dot is in lieu of a multiplication sign, because when you start getting to algebra, the X sign that you know is multiplication now actually stands for the letter X in algebra. So L times W times H to find the volume of each individual prism, and then add up the volumes to find the total volumes. It's like filling up two separate containers and then adding them up at the end to combine everything. So let's go ahead and get started with number 1 here. It says find the volume of the blue rectangle prism first. So we have a blue one over here. And you'll notice that we have some dimensions to try to figure out what they mean. So the blue, I noticed that it is 3 inches right there. So from that side to that side is 3 inches. I also noticed that this blue is 9 inches high from there to there. But when we do volume, we need 3 dimensions. I basically have a height, I have a width, but I don't know one of the measurements. I don't know how far it is from this side to this side. So where can I find it? Is that somewhere else on the picture where you can use that? I know there's a lot of numbers written on there. Well, if you look, this width would be the same as way over here. This width it says right there is 5. So I need to use that one. It might not be right where they're telling you to work. So this width is the same as that width. So I would have a 3, comes from right there. I would have a 5, and I have a 9. Okay, so there's that one. I have a 3 by 5 by 9. Now, to find the volume of all of those, all we need to do is multiply those 3. And again, order doesn't really matter. But if we did 3 times 5, I get 15. 15 times 9, so 15 times 9 like that. 9 times 5, 45. 9 times 1 is 9. 9 plus 4 would be 13. 135. So that one is 135 cubic inches. That's, inches to the third power, cubic inches. Now, volume number 2. Now, they want me to find the other one that is not blue. Okay, so I want to find this brownish colored one. So we need 3 measurements. Well, now I noticed that this side is 15 inches. But I don't want to write 15. because this length, if you'll notice, has some blue and some brown. I want to know just the brown. Well, if this whole thing is 15, how much was it right here again? How much is this? Excellent. Yes, Justice, this would be 3. See, this is 3, so that's 3. So if this is 3 and the whole thing is 15, how much for just here? What am I going to do with that 3? Yes, I subtract it from the 15 because the whole thing's 15. Take off 3, that leaves me with 12. So I know this side is 12. That's one thing you'll notice. You're going to have to maybe doing a little bit of subtracting to find some areas, maybe even some adding. There's this side, and now I know that it is 5 wide, much like the other one, the blue one. And it is, again, this side is also 3. So there's my 3. And again, order doesn't matter. I have 12 times 5 times 3. Well, hopefully you've been working on your math facts. 12 times 5, we know that is 60. And 60 times 3, well, we know 6 times 3 is 18, so it should be 180. But I'm not done, because when we're doing a composite solid, I need to add up all of my solids to find the overall. So I'm going to take my 135 and add to that 180. So let's do that maybe in the wide open space on this side. So I have 135 and 180. Add those up. 5 plus 0 is 5. 8 plus 3, 11. 1 plus 1 plus 1, 3. 315 cubic units. So the whole entire shape would be 315 units. Now, would that be the same thing what if I didn't see it that way? Because they're not always going to draw the lines there. What if you want to do the blue this way? Well, let's do the blue first this way, just doing the same shape, just the other order. And I'm going to have the bottom go all the way through this time. Notice the difference in the color. So now let's start with the blue one. This side is 15. Okay, so that one is 15. It is again 5 wide and 3 tall. And now, again, order doesn't really matter. What if I said 5 times 3 is 15? And 15 times 15, I already know, is 225, something I had to memorize years ago. Now, we're left with the brown. It's with the brown here. Now, I see that that's 9 tall, 3 there, and we did the other one. We knew this one right there, the width of this one was 5 right there. But is there a number in there that we can't use as they have it? Because if you take a look, it's not all brown by the number. They said 9 here, but that's including the brown and a little blue. So we got to get rid of that. Well, if the whole thing is 9, and this part right here is the same width all the way across, so this is worth 3 right there, how much is left for the brown? Yeah, that leaves 6 right there. So I have, let's say, 6 by 5 by 3. So 6 times 5 is 30. 30 times 3 would be 90. Again, so I add up my 225 plus my 90. So 225, add to that 90. 5 plus 0, 5. 1, 3. Now, you notice that in both cases, we came up with the same number. Even though our numbers were different, we still got the same overall. It all just depends on how maybe you see it. And this will make sense on the next page when they are not maybe going to color them like this, where it's this same looking shape, but now they don't color it. And again, I don't know which way you're going to see it. Maybe you want to see the bottom going through and doing the bottom. Maybe you want to see this going all the way through. It doesn't matter which one you do. So let's just say, you know what? I'm going to pretend like this goes all the way down. So I'm going to find this right there. And so what I'm going to do is let's find this shape first. Okay, I like to circle. So it's like, okay, I'm finding this shape first. Now, I know that it is 15 tall on one of them. So let's say we have 2 different volumes. So it's 15 by, how wide is this? This looks like it is 5. It's kind of blurry on my picture. I'm hoping I'm using the same numbers and they're right. 5. And then I don't know this right there. How wide is that right there? Well, again, that looks like it is 8. So 15 times 5 times 8. Again, order does not matter. Let's take 5 times 8 is 40. So I have 15 times 40. We can do it anywhere on here if you'd like. So 15, 40. 0 times 0 or 0 times 5 is 0. 0 times 1 is 0. Move over, moving down. So I go 0. 4 times 5 is 20. 4, 5, 6. So 600. So this shape right there is 600. Talking about centimeters cubed. Now I have this shape to do. Now I notice it says this thing is 24 along the bottom, but I've already counted this much of it. So I got to figure out how much is this right there? Well, if you remember, it said 5 right there. So if this is 5 and this whole thing is 24, that means that it's 24 minus that 5, which would leave me with 19. So I have a 19 by 8 by 5. So I have a 19 by 8 by 5. 19, 8, and 5. And multiply those. Again, I know that 5 times 8 is 40. So I'm going to take 19 times 40. Let's do that. How about right over here? Yeah, maybe right here. 19, 40. Again, 0 times 9, 0. 0 times 1, 0. Move over and move down. So I move down there. 4 times 9 would be 36. 4 plus 3, 7. So that one of the volume 2 is 760. Again, this is in centimeters cubed. To find the whole volume, though, I need to take this one and add it to that one. So I have 600 plus 760. So let's do that right here. 600 and 760. 0, 6, and 13. So 1,360 centimeters cubed for that shape. Okay, I'm going to draw a little line here so we don't get confused with all the numbers, and I'm going to do the next shape. Now this one kind of reminds me of like an old Tetris piece a little bit. The way I see this one, you could break it into 3 pieces, one there, one there, one there, but that would be more work, I would think. So let's break this one off like somebody, like a shape is wearing almost like this little hat up on top. Let's first find this bottom shape. So I want to find this whole shape basically right there. Okay, like just that solid block in the bottom. I see it's 14 by 5, and it's 3 tall. So I have a 14 by 5 by 3. Again, this is a 5, so I kind of cross that one out. Okay, 5 times 3 is 15. So I have a 14 times 15. Let's do that right here. 14 times 15. 5 times 4 is 20. 5 plus 2 is 7. Move over, move down, done with that one. 1 times 4 is 4, and 1 times 1 is 1. Add them up, 0, 11, and 2. So I know this bottom piece right there is 210. Here we're talking feet cubed now. That's cubic feet in the bottom. But now I have to do the top. Okay? I see it's 4 wide. I see it's 2 tall. But how long is this right there? What's that side? Right, it's the same as this width. They're all the same. So it would be 4 by 2 by 5. Remember, it doesn't matter what order you write these numbers. 4, 5, 2, whichever order. Just know that's 4, 2, and 5. 4 times 2 is 8. 8 times 5 is 40. Now add them up. I have a 40 on the like a hat thing. I have 210 for the bottom. So if you add them up, you'd get 210 plus 40 equal 250 cubic feet. I could also write it as cubic feet like that. So 250 feet cubed or cubic feet. It does mean the same thing. Okay, nice job on that one. Let's try the next page now. We are going to do a couple buildings. This one, you could kind of looks like a school, and the bottom one might look more like a school than the top one, but you can, I guess there's garages in it, so let's maybe say it's a warehouse, it says. This building consists of 2 rectangular prisms. So we have this large prism right there, and we have a smaller prism right there. A small space for offices, and an attached larger space for warehouse storage. How much space does the building take up? So I need to find both of these buildings. Let's do the large one first. I see it's 50 along that way. It's 30 along that way. And how tall is it? It's nowhere here, but it's way over there, 12. So again, we have a 50 by 30 by 12. I don't know any of these on top of my head, but a long time ago, we were working with numbers with zeros, and 5 times 3 I know is 15, and there are 2 zeros. So that one was actually pretty easy. Now I take that one times 12. So we could take 1500 times 12. That's 0, that's 0. That'd be 10, another 0. Then 2 plus 1 is a 3. Now I'm done with that one. Move over, move down, put a 0. 1 times 0, 0. 1 times 0, 0. 1 times 5, 5. 1 times 1, 1. I'm up 0, 0, 0, 8, and 1. So the size of this building right there, how about I write it right in the building? 18,000 cubic meters. That's a lot of space in there, especially when you're talking in meters. Meters are big. Okay, but now I have a small office building right there, and I see that it's 15 by 5 high and 10 deep. So I have a 5 by 15 by 10. How about 5 times 15? 15 times 5 is 75. And now 75 times 10. Well, anything times 10 is easy. Just put a 0 at the end. So the second building right there, this is 750 because you put 0 on the end. 750 and 18,000. But to find the overall, I need to add them up. Well, 18,000 plus 750 is pretty simple. 18,750. But we're dealing with meters, so we can put cubic meters, or again, we could have meters cubed. And the last one on this page right down here, we have this. Now this one to me looks like a school. You maybe have like the 3-story building, 1-story, and a 2-story. Okay, let's look at this one. A lot of numbers. It looks very confusing at first. This one we're gonna have to break into 3 pieces. So let's just start with this one. Maybe you want to kind of go like this and realize, okay, this is going to be one building right here. So let's do this building right there first. Okay, a lot of numbers. Now let's just go with what we know. I know it's 30 feet tall. Okay. I know it's 25 feet wide. How deep is it? It is 20 feet deep on that side. So those are my 3 numbers. So I have a 30 by 20 by 25. Well, 30 times 20, well, 3 times 2 is 6, 2 zeros, so 600 times 25. You can do that one. Let's see, how about right next to it here? 600 times 25. If you have a calculator, you can use that on here. We're not really asking you to do the multiplication. Well, we want you to do the multiplication, but we're not testing you on multiplication. So if you want to use a calculator for this, you sure may. 5 times 0 is 0. 5 times 0 is 0. 5 times 6, 30. I'm moving over, moving down. 2 times 0 is 0. 2 times 0 is 0. And 2 times 6 is 12. Add them up. 0, 0, 0, 5, and 1. So the big building right there is 15,000. Now we're dealing with feet, so we can put cubic feet, feet cubed. Now let's see, how about we do the other big building this side? So I want to do this building basically right there. I'm going to do that side. Now I see it's 20 feet tall. I see it's 20 feet wide, and this one is also 20 feet deep. So we have a 25 by 20 by 20. Well, I know that 20 times 20 is 400. So I have a simple 25 times 400. So let's do that one right here. 400 times 25, 0, 0, 20. Put a 0, move over, move down. 2 times 0 is 0. 2 times 0 is 0. And 4 times 2 is 8. And all we have to do is add them up. We have 0, 0, 0, 10. So this building here is 10,000 cubic feet. And now we're at the middle, probably the hardest one there is. I know there's a lot of drawing, a lot of numbers going on, so it might be kind of hard to focus, but I see it's 25 feet wide. How deep is it? Well, this depth right there would be the same as this building and this building, which was 20 in both cases. So right now, we know this one is 25 by 20. But what I don't know is how tall this building is. Now I'm looking everywhere. I don't see it. It doesn't tell me anything. So let's go through what we know about height. Let's just focus on height. I know this building is 30, the tall one right next to it. I know this building is 20. But that doesn't really help me. Is there another height somewhere that we need to see? If you look in the back, if the whole building is 30, and the difference from the short building to the tall building is 20, what is left for the small building? Correct. That has to be 10 feet tall. So 25 times 20 times 10. Well, I know that 20 times 10 is 200. So I could take 25 times 200. Let's do that one maybe way over here. 200 times 25. 5 times 0, 0. 5 times 0, 0. 5 times 2, 10. Move over, move down. There. 2 times 0, 0. 2 times 0, 0. 2 times 2 is 4. Add those up and I get 5,000. So the middle is 5,000. So I know a lot of writing right there. So I have a 5,000 for my small one. I have a 10,000 for my medium one. And I have 15,000 for my big one. All you gotta do is add them up. 5,000 plus 10,000 is 15,000. 15,000 plus 15,000 would equal 30,000 cubic feet. Now we're doing that because they want to know for a furnace, which is very important when you're going to be putting a furnace in, how much cubic feet of space. Because then when you're moving air through a furnace, it is a three-dimensional shape. Excellent job with that one. Only one more page left, and this one only has one question. It is kind of a doozy, though. If you wanted to, you could try pausing this one and trying it on your own if you would like to. Obviously, I'm going to go through it. But if you wanted to try it, this one's a little harder because there's kind of an extra step in this one that we haven't done in the previous two. So an in-ground swimming pool often has steps. These are made from poured concrete. In the sketch at the right, the steps are identical, each measuring 18 inches from side to side, 12 inches from front to back, and 8 inches tall. Calculate the amount of concrete that is needed for each step. So let's do the first step. Now remember, this step is only going to encompass this volume right here, okay? If I wanted to draw in between there, so you kind of get a three-dimensional shape. So I'm just doing this block right there, which we know that this one is 12 by 8 by 18, okay? Well, let's just multiply 12 times 8. For this one, though, let's go ahead and let's use a calculator to make it go a little bit faster because now my recording is getting kind of long. So I'll try to squeeze my phone in here with this. Okay, here we go. So I have 12 times 8 times 18. So that bottom step right there is 1,728. But now my next step, if you take a look, most of the measurements are the same. I am still 18 inches wide. I'm still 8 inches tall right here. I'm still 12 inches deep right there. But remember, this would only be for that. Well, there's more than that. Notice how this step is like 2 of them. Because it's not just 8 inches tall. How tall is it? It's now 2 steps tall. So this would be 8 and 8 more. So this 8 turns into a 16. And so I still have the 12. I still have the 18, but that 8 was 2 steps high, so it's now 16. So now, let's see, I'm going to keep that one all by itself. Now I can take and multiply by 12 times my 16 times the 18. Now the second step was 3,456. Okay, and you might have noticed it's actually twice as big. You're starting to see a pattern. The third step, I am still 12 deep. This one is still 18 wide, but tall. This is 8 inches tall, but it's also 8 inches to the second step. And then 8 inches is the third step. I'm kind of drawing that three-dimensionally, how you can see how this shape would be encompassing all that. So I'm still 12. I still have my 18, but what's my middle number going to be? Correct, 24. So let's go ahead, and I have 12 times, oh, let's move over here so you see better, 12 times 24 times 18 equals 5,184. And now I have all three steps in here. So if I take that number, let's add it to 3,456 and add that to my first one, which is 1,728. That equals, now we have our steps encompassing 10,368, and we are measuring in what? Cubic inches. That's how much concrete that would take, cubic inches. But don't try to order that much from the concrete company because they want how many cubic yards you have, which would be a whole new way of doing it, and I won't tell you now. But if you ever want to know, you let me know and I can teach you, because concrete is measured in cubic yards when you order it. I appreciate you tuning in today. Thank you. If you have any questions, again, feel free to reach out to me or any one of your fifth grade teachers. Have a good rest of your day. Thank you.